Good day, Dr. Nolana. We are from Group 2, and today we will present our group project. The title of our project is Permohonan Kelulusan Pelambangunan untuk Membina dan Menyiapkan satu unit rumah bergebar satu tingkat jenis kekal di atas nombor 6, Jalan Setia Arujina, U131F, Setia Alam, 40170 Shah Alam, Selangor, Darul Esa. This is our group members. We total have 7 people inside our group. This is table of contents for our slide. We have introduction, excavation for ground beam, concrete for ground beam, formwork for ground beam, one brickwork, 300 mm by 300 mm floor tiles, weather shield, painting, formwork in column, and reference. In the construction industry, accurate measurement and documentation are critical components that bridge the gap between architectural design and financial. The primary aim of this project is to develop the technical proficiency and practical skill in construction quantification. By engaging with this project, we will achieve the following core capabilities such as standardized measurement. We will accurately measure building elements in strict accordance with the Malaysia Standard Method of Measurement of Building Works (SMM2). Second is BQ preparation, with aligned with the standardized guidelines set by SMM2, and utilize appropriate measurement and taking of paper to maintain systematic and industry standard documentation. Furthermore, by creating a bills of quantity, we can learn how to structure a professional BQ such as preliminary, the indirect cost of a project such as site insurance, temporary scaffolding, site office, and so on. Second is building work, the direct cost of material and labor for the physical structure. The last one is we can gain our hands-on experience by using traditional QS paperwork like dimension paper to calculate the length, weight, depth, and depth, and taking off list. So this project is a collaborative that simulates industry practice, helps to develop a rigorous, detail-oriented approach to construction measurement. Next, I will be presenting the measurement and taking off process for the excavation for ground beam. Our main objective is to excavate pile cap and trenches for ground beam between piles stating the starting level as closest D11. In accordance with the SMM guidelines, all excavation work are measured by volume using cubic meters as our standard unit. To find this volume, we apply the standard formula which is length multiply weight multiply depth. Furthermore, to ensure accuracy in this dimension, we will refer our ground floor beam details plan to get the exact physical dimension of each individual beam type. At the left side, we systematically broke down the calculation by beam mark to avoid confusion or double counting. For example, the GHB2, which size is 150 mm multiply 500 mm. So we took the clear length is 6705, which refer from the plan, and we multiply it with the weight and depth. So the calculation is 6.71 times 0.15 times 0.5. So the total cubic meters will be 0.5. So we will repeat this process for all beam types including GHB4, GHB6, GHB10, and so on. So we will adjusting the width and depth to match their respective schedule. For example, the GHB 10, the width is 200 mm, and GHB 14, the depth is 600 mm. So we will refer the ground floor beam details plan to ensure the width and depth. And every beam type, we will calculate the length by referring the architecture drawing plan. Last, the photo on the bottom right illustrate the actual site reality and the result of our taking off data. And this is what the excavate track look like on site, ready to receive the lead concrete blinding and the ground beam reinforcement catch being prepared. By ensuring our taking off closely this actual site condition and strictly complies with SMM Clause D11, we also have prepared a accurately bills of quantity. That's all for me. Thank you. For further information for excavation for ground beam, this is all the beam types we have already calculated, and the right side is taking off list for the work below lowest floor finishes.
Next, we move to concrete for ground beam. For ST1 column stump, we got 0.05 meter cube. For C1 column stump, we got the total of 0.19 meter cube. For C1A column stump, we got 0.04 meter cube. Next, C2 column stump, we got 0.09 meter cube. C3, 0.05 meter cube. And last C3A, we got 0.09 meter cube. So the total of column stump is 0.51 meter cube. Next, we move to pad footing for concrete work. For F1, pad footing F1, 0.15 total meter cube. For F3 pad footing, we got 0.62 meter cube. For F4, we got 1.13 meter cube. For F5 pad footing, we got 3.68 meter cube. And last, for F6 pad footing, we got 3.96 meter cube. So the total of pad footing, we got 9.54 meter cube. Next, ground floor slab for concrete work. For area A, we got 2.90 meter cube. For area B, 2.97 meter cube. And for area B1, we got 2.47 meter cube. For area C, we got 0.97 meter cube. And the total of ground floor slab is 11.26 meter cube. Next, we move to concrete work for ground beam. For GHB2, we have 0.50. For GHB4, we have 0.50. And GHB6, the total is 0.58. For GHB8, the total is 0.55. GHB10, we have 0.55. For GHB12, we have 0.13. For GHB14, we have 0.41. And GHB16, we have 0.11. And for GHB18, we have 0.11 also. And in the last, for GHB20, we have 0.28. So the total of ground beam ground beam is 3.92 meters square. For apron slab concrete work, for area 1, for area A we have 0.23, area B 0.23 also, and area C we have 0.20. For area D we have 0.67, and area E we have 0.15. For area F we got 0.71, and lastly for area G we got 0.82. So the total for apron slab we got 3.21 meters square.
Assalamualaikum. We present my part homework for ground beam. Measure the length of each ground beam and multiply it by the beam depth to calculate the formwork area for each beam. Then add all the individual beam formwork areas together to obtain the total ground beam formwork area. Total ground beam formwork area is 5.89 millimeter square, and total ground floor slab area is 144.66 millimeter square. That's all for me. Thank you.
For the internal wall, the total vertical wall length is 33.15 meter, while the wall height is 3.50 meter. Multiplying the length by the height gives a total wall area of 116.03 meters square. There are two deductions for this wall, namely D5A and D4, each measuring 1.47 meters square. Therefore, a total net area for the vertical wall is 113.09 meters square. Next, the total horizontal wall length is 46.80 meter, with a wall height of 3.50 meter. Multiplying the length by the height gives a total wall area of 163.80 meter square. For this section, there are 4 deductions with a combined area of 6.72 meter square. After deducting this amount, the final net wall area is 157.08 meter square. Next, the total length of the dam proof cost is 79.95 meter. This value is obtained by adding the two wall lengths, 33.15 meter and 46.80 meter. Finally, for the bonding ties, its total quantity is 126 knots. This figure is calculated by multiplying 9 multiple 2 multiple 7. That's all.
For the internal floor finishes, the foyer, living room and dining room, guest room and kitchen use 300 mm times 300 ceramic floor tiles. These tiles are durable, easy to clean and suitable for areas with frequently daily use. Bedroom 4 and bedroom 5 use 150 mm times 150 mm ceramic floors tiles to provide better grip and reduce the risk of slipping. Meanwhile, store 1 and store 2 use similarly because it is economical, durable, and suitable for storage areas.
Now, I will present about the final net area for the internal wall finisher. Okay, the first step is total wall length 33,150 mm plus 46,800 mm to so the total is 79,950 mm. Wall height, the architecture ceiling height is 3,500 mm. So gross total area multiply length by height give us 79,900 50 mm, square 3500 mm. So the total 279,82500 m square 2. Okay, so convert to m is 279.83 m2 square for the final squaring column. Okay, the second step is deduction opening. For example, like door 3B. Okay, the door measurement on the plan 900 wide by 2000 100 mm height. Multiplying this gives us an opening area of 189,000 mm 2 square for the single door, equal to meter 1.89 for 2 square. So the final conclusion is total deduction area for all 5 door on this shade 8,190,000 mm 2 square, convert to m 8.19 m2 square. So the gross wall area 279,825,000 m2 square, less total door deduction negative 8,190,000 mm2 square. So the net international wall finisher area is 271,835,000 mm2 square. So convert to m is 271.64 m square 2. In the squaring column is what we transfer direct to our bill of quantities BQ. This ensure to contractor order the exact amount of plaster, paint or tiling required for the project without costly waste. That's all.
Next, element frame formwork in column. The first step is to find the grade. Grade means the total perimeter around the column. It is calculated by adding all 4 sides of the column cross section. This grade is then multiplied by the column height, then determine the total formwork area in square meters. The same method is used for all the other columns typed on the page. Given here, the height was 3000 mm. For example, ST1 150 mm multiplied by 2 and 300 mm multiplied by 2, then it equals to 9,000 mm. Then the 9,000 mm we multiply the height of the column, which is 300 mm or 3.00, and the answer will be 2.70. That's the total perimeter. This schedule helps the site team prepare the correct size and quantity of the formwork before concrete casting. It ensures that each column is constructed according to the design dimension, minimize material weightage, and improve efficiency during installation. Overall, the formwork schedule serves as a guide for fabricating, assembling, and estimating the column formwork required for the project.
This is the reference of our BQ. That's all for us. Thank you.